Measuring solutions. Let's look at concentrations of solutions. Let's look at what it means. Now, concentration means the measure of the amount of solute, like your Kool-Aid, dissolved in a certain amount of solvent, like the water. A concentrated solution has a large amount of solute. For instance, here we have water, and we want to make our Kool-Aid, but we want to concentrate it. We want to give it a good kick. So we're going to add all this Kool-Aid just to this one little glass of water. That's going to be muy concentrato, muy concentrated. It's going to have a lot of solute in a little bit of solvent, especially if we add all this stuff. So we're going to have cherry and Jamaica blend and pink lemonade, all these good tasty Kool-Aid stuff. Now, a dilute solution will have a small amount of solute per given solvent. So for example, if we want a little dilute solution, let's say we're going to go to the corner and sell Kool-Aid, but I don't want to spend all this money on Kool-Aid. I'm just going to go to the hose, fill up this big jug with water, and just put a little tablespoon of sugar. Then I'll add some food coloring. This is going to be very dilute, a small amount of solute. This is what those fast food restaurants do. They have a very dilute cola. If you go, I don't know if they even have these anymore, these self-serve cola machines, you can just see the water coming out and just a little bit of the cola as you fill up your cup. But that's the way they make money. In fact, you make most of your money off of the cola. Now, this is different than being saturated or unsaturated. Okay, these are different. Now, concentrated and dilute are really subjective terms. Now we come to the cool thing of molarity. Anything dealing with moles is cool. And often you guys might see a big M on the side of a bottle like acid, like a 2M or a 1M or a 6M. We've done labs, and now we're going to see what this M means. Well, it has to do with big M moles. And what it means is it's a number of moles of solute, like moles of Kool-Aid, in a 1 liter of the solution, like water. Usually that solution, or really solvent, big M is moles per liter. So whenever you see that, such as on the side of something or in the directions for a procedure for a lab, big M is moles per liter. Let's try a problem here. What is the molarity of a solution with 2 moles of sodium chloride in 4 liters of solution? What do they give us? Moles is 2.0. Volume is 4.0. So moles of liter is really moles over volume. And let's plug that in. Let's see what we get. Molarity just equals moles over liters. We need to put our units there. 2 moles over liter, and we have 0.5 molarity. So that's our molarity, 0.5. Doesn't have that many moles, not even 1 mole per liter. Whereas something with 6 molar has 6 moles per liter. That's a high molarity. Let's try another molarity problem, because everything with moles is fun. What is a molarity of solution with 3 moles dissolved in 250 mils of solution? So the moles, 3.0 mole per 250 milliliters. Remember, it's in liter of solution, so it's 0.25. We have to convert that to liters. We get a molarity of 12. That's a high concentration. 12 moles in a liter. Intense. Some of these problems you're going to have to actually come up with the moles yourself. If you're given a certain number of grams of solute, you'll have to calculate the number of moles, but we've done that hopefully about 5 billion times by now. So it should be, not even thinking of any, it should be very easy. For making solutions, we want to pour in a small amount of solvent, such as water. Then we're going to add the solute and dissolve it. Then we're going to fill to a final volume. So using basic simple algebra, we can figure out the number of moles moles times liter equals, or excuse me, molarity times liter equal moles. Now let's look at this. How many moles of sodium chloride I need to make 6 liter of a 0.75 molarity NaCl solution? So oftentimes you're going to have a lab where you're going to need to prepare something, such as I'll have to do this. I'll have to make 6 liters of a 0.75 molar solution, and so I'll have to use this equation. I just rearrange it. So I just use what we're given. The molarity is 0.75 liters, 6.0 for volume, and we just multiply them together. 0.75 times 6 equals 4.5 moles. Now here's a little different. How many grams of calcium chloride are needed to make 625 milliliters of a 2 molar solution? So we want to know grams, but once we get moles, we can get grams. Fun stuff. All right, let's just first change 625 milliliters to liters. That's 0.625 liters. We multiply that molarity times liters, 2.0 molarity, and we get moles. 1.25 mole of calcium chloride. Now we know, because we have the moles, we can go anywhere with the moles. We can easily get grams from the mole by what we've been doing. Over 1 calcium chloride multiplied 1 mole of calcium chloride is going to be 111 grams calcium chloride. The moles cancel out when we get 138 grams calcium chloride. So we're going to need 138 grams if we want to make 625 milliliters of a 2 molar solution. Let's look at this one. We have 10.3 grams of sodium chloride that are dissolved in a small amount of water, then diluted to 250 milliliters. What is that concentration? Okay, well, we know 250 liters is 0.250 liters. We're given 10.3 grams. We want moles per liter. Concentration, of course, is moles per liter. So we need to change 10.3 grams to moles. Easy stuff. We've done this before. 10.3 grams sodium chloride. 1 mole sodium chloride. And we get 0.17 mole of sodium chloride. All right, we got our moles, and we're going to put it over our liters. So 0.175 mole per liter, 0.250 liter equals 0.7 molar. So if you say molar, it's the same thing as saying molarity. We just like to not have to say big long words. So a molar is the same as molarity. How many grams of sugar are needed to make 125 milliliters of a 0.5 molar C6H12O6 solution? We want grams. We have the molarity at 0.50, and our volume is 0.125 liters. Molarity is mole over liter, and so we're just going to multiply liters times molarity to get our mole, and then from mole we can go to grams. 0.125 times 0.5 equals 0.625 mole. Now we want to get grams from that. 0.0625 mole of C6H12O6. Multiply that. We have 1 mole of C6H12O6 is 180 grams C6H12O6. And we get 11.25 grams. So that's how much we need if we want to make a 0.5 molar solution in 125 mils. What about dilution? We're often called upon to dilute something. So for labs, we might need a 1 molar solution of hydrochloric acid, but this happens all the time. I have a big jug in an acid cabinet of 6 molar solution, but I only want 1 molar, so I have to dilute 6 molar to get the 1 molar, because we don't always want to use 6 molar. That's very concentrated acid. Right? Sometimes we want to use 2 molar. Sometimes I want 3 molar. So we'll have to dilute it. So what that is, we're adding solvent to a solution, and usually that solvent is water. The number of moles of solute doesn't change if you add more solvent. So that's important. You're going to still have the same number of moles. It's just like if you add a packet of that not high C, but the Kool-Aid to 1 cup, then you dilute it by adding it to a big jug, it's still the same number of high C or Kool-Aid sugars, same amount of solute, it's more solvent. The moles before equals moles after. We use that information to come up with this nifty equation. It's also pretty straightforward and easy. The key here is really getting the units correct. M is concentration, we know that. That's molarity, and V is volume in liters. Stock solutions are pre-made to a known molarity. Let's try this. We have 2 liters of a 0.88 molar solution, and we dilute it to 3.8 liters. So that means we add solvents. We add usually water. What is a new molarity? So let's just put this out. Volume 1 is 2.0 liters. Molarity 1 is 0.88 molar. V2 is 3.8. What is M2? Let's use this equation, and 1V1 equals M2V2, and we're just solving for M2. So we get a 0.46 molarity, or molar of 0.46. Diluted it by about half, a little less than, so by adding all that water. So 3.8 liters, that's actually a lot of water. Let's try this. If you have 150 mils of 6 molar HCl, what is the volume of a 1.3 molar HCl? Or what volume can you make of 1.3 molar? What's the new volume going to be? So obviously we diluted it. How much water did we add to it? So let's put this in. M1, 6 molar. V1, we have to be careful. We have to change it to liters because molarity is moles per liter. We have to change it to 0.15 liters. M2 equals 1.3 molar. V2, what volume will we get out of it? So we get 0.69 liters.